I am Kumar. Welcome to my series on understanding parametric equations. Now this topic is not really dealt in details in many books, so I thought I'll create a video with different types of examples. So here we'll talk about 5 parametric equations. We'll also understand what really a parametric equation is. Let's look at these equations given to us. A is x equals to 2 plus t, y is 3 minus 2t, where t belongs to real numbers. So in this equation, you see the term t, and t could take any real value. So t is called the parameter. So in this case, when we say this t, which belongs to real numbers, then t is our parameter. Parameter really means that in this equation, we could get different points using different values of t. And then we get a curve. And that is described by this set of equations, right? Now, let me also tell you that this set of equations, x equals to 2 plus t and y equals to 3 minus 2t, will actually represent a line. We will see how, and we'll also see how to sketch this. The second one is x equals to 3t, y equals to 3 over t. Now, since t is in the denominator, I should add here that t is not equal to 0, right? Now, this type of an equation will represent what? It will represent, we will see, it will represent a reciprocal function. Like y equals to 1 over x types. Then we have one equation which is x equals to 1 plus s. Now, as far as the parameter is concerned, you could write t, you could write s, or any other alphabet, right? Most of the time we use s and t. So the third equation is x equals to 1 plus s and y equals to 3 plus s squared. Now that x square term gives you an idea that this could be a quadratic equation, or it could be sketched as a parabola. Then we have trigonometric functions coming up. We have x equals to 3 cos t, y equals to 3 sin t. T could be any real number. Now, it is not necessary that we always put t equals to real numbers, right? We could sometimes provide t in a limited range also, right? So we could say, well, t is between two numbers. Let's say it's between 0 degrees to, let's say, 360 degrees. Or we could use in radians 2 pi. So in this case, we are taking t as in radians from 0 to 2 pi. We'll show you that this actually represents a circle. We have a very similar looking equation here where we are writing x equals to 2 plus cos t and y equals to minus 1 plus sin t. Now this also will represent a circle, but this 2 and minus 1 gives you translation. That means this center was at origin and this center is at 2 minus 1. Okay, so both represents a circle. So we do have many types of equations. We could create many types of parametric equation to represent different curves. Right, that's one thing. So we'll look into the exercise, how to sketch them. Strategies to sketch are kind of like this. We could have a set of points. Strategy 1, to draw a curve. Curve could be, you could find Cartesian points, right? So you could do substitute values of parameter t, right? And find coordinate xy, right? So once you substitute different values of t, you could find the different coordinates and then you could connect them with a smooth curve. Now the curve could be a straight line, as we have seen will be the case for A and B. Correct? So that is what we are going to do with each one of these equations in this video. So this video could be about half an hour long. So the very first equation which we want to work with is x equals to 2 plus t and y equals to 3 minus 2t, where t belongs to real numbers. And what are we going to do with this is we are going to sketch the graph represented by the parametric equation. Right? You understand clearly why it is parametric. Well, you should also see that line is set of points in a direction, right? So that also gives you a parameter, one dimension. So that t is one parameter here. Okay. To find the graph, as I was saying, we could do find some Cartesian points. So I'm making a table here. And what we'll do here is that we'll place some values for t and find out x and y coordinates. Right? Okay. So let's say we'll give some values of t. Let me write here itself. And then we'll calculate what is x and what is y. So you could begin with any value you want. Let's begin with 0, right? Okay. So let's say we put 0 here. So we'll put negative values and positive values. So let's say negative 1, negative 2, 0, 1, and 2. Let these be the values for t. So if I substitute 0 here, I get x and y as 2 and 3. If I substitute 1 here, 2 plus 1 is 3. And 3 minus 2 will give us 1. Substituting 2 will make it 4. And here substituting 2 will give us minus 1. Correct? Similarly, by putting the value minus 1 for x and y, we get 2 minus 1 as 1. Minus minus makes it positive 5. And minus 2 will make it 0. And minus 2 here will give us minus 4 plus 3. Minus minus is plus 4. 4 plus 3 is 7. So that is what we get. Now if I try to plot these points, so you can see the coordinates are what? So the coordinates here can be written as x and y coordinates. These are 0, 7, right? For t as minus 2, 1, 5, 2 and 3, 3 and 1, and we have 4 and minus 1. So these are the coordinates which we could plot on a Cartesian plane, right? So that is why we are saying Cartesian and parametric equations. We'll also see how to convert one form to the other in this video. Okay. So we have to basically plot these points, which are 0, 7, 1, 5, 2, 3, 3, 1, and 4, minus 1. So we have to begin with a high positive value. So most of them are in coordinate 1. So I'll focus here. So as you can see, the first point could be 0, 7. So let's say 1, 2, 3, 4, 5, 6, 7, 8. So the first point is 0, 7. Okay. And here let's say 1, 2, 3, 4, 5, 6, 7. Okay. The second point is 1, 5. So at 1 we have a value which is 5. And then we have 2, 3. So 2, 3. So it is kind of coming down, right? And at 4 we have minus 1, correct? So 1, 5, 2, 3. So 2, 3 is like this. And then we have 3, 1. So at 3 we have 1. And at 4 we have minus 1. Okay? So when we connect these points and extend them, so 4, 1, 2, 3. So this is not really exact value, but gives you an idea of how to sketch. Right? So the whole idea is to understand the concept, right? So we get a line here where this point for us is 4 minus 1. Is that clear to you? So what you see really is a line, right? So on a Cartesian plane, the parametric equation will represent a line. This Cartesian equation. Now mathematically, we can actually show it also. How can we do it? Let's try to figure this out also. That's kind of important. So we'll convert this parametric equation to the Cartesian equation. We could actually isolate t from the first equation, x equals to 2 plus t. So from here we get t equals to x minus 2, right? Now I can substitute this value of t, x minus 2 in the second equation. So we get y equals to 3 minus 2 times t, which is x minus 2. Clear? Now let's continue. We could get this as 3, open the bracket, minus 2x plus 4. Or we could write this as minus 2x plus 7. So what do you get? You actually get the equation of a line which is y equals 2. So that gives you an equation of the line which is y equals to minus 2x plus 7. Clearly, we do get a y-intercept here, right, which is at 7, right? So that works. And the slope is minus 2, as you can see. From 7 it goes to 5. And so we do see that the slope here is minus 2, right? So as we move here, we know m is minus 2, which is constant. So you could actually get the equation from the points derived or from the equation as we have just done. Now this process is very standard process, right? So that is the strategy. Let's learn this to convert parametric equation into Cartesian equation. Is that clear? So I hope you got the concept about it. So whenever you're given a parametric equation, remember that t type of a variable is a parameter which could take different values as decided in the equation itself. Using different values of t, we could get some coordinate points, plot them, and see what exactly it represents. Equations can also be transformed by different techniques. Here we isolated t and then substituted to get an equation in the form of y equals to mx plus b, which represents a line for us. Is that clear? Now with this in mind, I'd like you to make an attempt to find out what kind of graph will this parametric equation represents. So you can now pause the video, answer, and then look into my suggestions. So I hope you must have got what type of graph is this. Here we are given the equation as x equals to 3 times t and y equals to 3 over t, right? And we are also given that t is not equal to 0 and t belongs to all real numbers. So the strategy which we can adopt is basically we need to somehow get rid of that parameter t to get Cartesian equation, right? So the strategy basically is to somehow find equation in terms of only x and y. So we have to relate y with x, right? Y as a function of x. Basically, we want to write what is y as a function of x. This is what we are interested in. So in that case, we need to somehow get t cancelled. And from this given scenario, it becomes obvious that we could multiply them, right? So if I do x times y, we get 3t times 3 over t, correct? Now t and t cancel, so we get just the number 9 here as x times y. So the product of x and y is equal to 9, correct? And from here we can get our relation y equals to 9 over x. Now that represents a reciprocal function, correct? Some constant over x. And if you substitute different values for x, you know what kind of graph you're going to get, right? So x is not equal to 0, right? So x is not equal to 0, right? So the graph will be kind of like this. You can actually substitute some points as we did earlier. Find x and y values, right? And then check for yourself, right? So if x is equal to 1, right? If x is equal to 1, then y is equal to 9. That is what it is, correct? So for x equals to 1, this point will be 9 for us. So this point will be 1, 9. And on the other hand, if x is equals to minus 1, then the point will be minus 9. Does it make sense to you? So those are the 2 points. These are the vertical and the horizontal asymptotes. Accordingly, you can select a scale and then sketch it. So I hope it becomes simpler now, right? Okay. Another example here is to show you, this is a parabola, and let's see how we can figure this out. Show that the given parametric equation represents a parabola. That means a quadratic equation, correct? Now here we are going to use the strategy of writing x in terms of s and then substituting. We have x equals to 1 plus s. We can write x minus 1 as s, correct? The other equation given to us is y equals to 3 plus s square, right? Now we can substitute the value of s right there. So we get 3 plus x minus 1 whole square, correct? So what we did was we substituted this value for s. Now what does that give you? So we have an equation here which is y equals to, let me write like this, x minus 1 whole square plus 3. Now that is a parabola, correct? That is a parabola. So we could now sketch this function. It is a parabola which has a vertex at 1, 3, right? So, okay, so and it goes up, right? So we could actually plot some points and also sketch. So what we could do is sometimes you could use now different techniques to find the values. So one could be that you could make a table where you can provide some values of x and find what y is, correct? And write down the coordinates. So if I write x as equal to 1, for example, I get y as 3, correct? If I write x as 0, for example, I get 1 plus 3 as 4. And if I write x as minus 1, it becomes minus 2 square, which is 4 plus 3, 7, right? So, and if I write 2 here, 2 minus 1 gives me 1 square plus 3, which is 4. And for 3, I get 4 plus 3 as 7, right? So for different values, we do get some values of x and y. So these coordinates are minus 1, 7, 0, 4, 1, 3, 2, 4, and 3, 7, right? So substituting some values, we get some coordinate points on x and y. We can plot these coordinates. And what do we get? Well, we will get a parabola. So putting these points here, what we get is something like this, which is a parabola where the minimum value here will be 1, 3, right? So this value will be 1, 3, correct? And the y-intercept at 0 will be 4. Do you see that part? So you get a parabola in this case, as we have shown you. Is that correct? So you have seen how easy it is to work with parametric equations and relate them to Cartesian equations. So that is a vertex form of a parabola, y equals to x minus 1 whole square plus 2. Two more examples to go, and these are for the circle. So the question here for you is, find the radius and the center of the circle represented by the following parametric equations. We have two equations here. Now, in many test papers, we have questions like this. So I've taken actually questions very similar to what you should expect in any good exam or test. Now let's look into these equations. We are given x equals to 3 cos t, y equals to 3 sin t. So what I could do is, I could write this as x square equals to 9 cos square t, and I could write y square equals to 9 sine square t, right? So if I write what is x square plus y square equals to, I get 9 times cos square t plus 9 times sine square t, right? Or we get x square plus y square equals to 9 times cos square t plus sine square t. And you know cos square t plus sine square t is 1. So we get x square plus y square equals to 9. So that is a circle, as you know. So we do have a circle here, and then now we can answer the question, which is find the radius and the center. So this is the circle with radius r as 3, right? 9 is 3 square, and the center is at origin. So center is at origin O, which is 0, 0. Is that clear to you? Correct? So that is how we can actually relate the parametric equation to Cartesian equation and then really work with it. Clear? Now, I hope you've understood this strategy. Let this be your test question, which is x equals to 2 plus cos t, y equals to 1 minus 1 plus sin t. Now this also represents a circle. This also represents a circle where you need to find what is its center and what is the radius. Okay, so you can pause the video, do it now, and then look into my suggestions. So let's work on this. So the first equation, what I will do is, this is the shortest method, x minus 2 equals to cos t, right? And the second equation I can write y plus 1 equals to sin t, correct? Now we can square and add them. So we get x minus 2 whole square plus y plus 1 whole square equals to cos square t plus sin square t. So that gives you x minus 2 whole square plus y plus 1 whole square equals to 1. And clearly we have a center of the circle at which point? What makes this 0, right? 2 and minus 1, right? 2 and minus 1. These values, correct? So that's kind of a transformed, translated circle, you can say. And the radius is r equals to 1 unit. So this is 1 square. Is that clear to you? Correct? So that is how easily we can work with these equations. I hope it makes sense to begin with. So we will have many questions related to a parametric equation, working with them, and I'll also show you how to find derivatives, equation of tangent lines, equation of normals, and many different applications with parametric equations as we move forward. But then first let's understand clearly what a parametric equation is, right? And remember that this parameter t could have any values. It could be natural numbers, integers. It could have a restriction. I could tell you that t is between some values, right? It is between, let's say, 0 and pi, right? In that case, it will represent a semicircle, for example. Perfect. So giving different values of t can give you a different kind of curves also. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.